Ruttimann. I'm the head of engineering at Groundwork. We are developing an open source tools that's around for a long time, and so we do all the legacy monitoring, but in the recent years we had to expand it as well for virtualization and especially OpenStack and other environments. So this talk I gave a year ago at the conference where you see the logo. I tried to change the logo and save it in OpenOffice. Didn't work out that well, so I flipped back to the original presentation. So what is this about? It's talking about how IT has changed over the last 10 years and how virtualization came in. So in the past, as a sysadmin, you had servers to deploy, you deployed the application, you defined the checks, you created a dashboard, and it was good to go. And you repeated that step in the data center. Not little automation was in there, mostly scripting, and was easy to go. You had time to define the monitoring, to define the threshold, defining everything. So that was the state of monitoring like 10 years ago. And the tools, there were many popular tools out there like Nagios, Cacti, and so on for doing that job. But then the whole network changed because you got more apps and VMs and devices, and the network and storage was through the network. So you got much more elements into it. And what really changed is like now everything was virtualized. So you have a virtualized network, virtualized storage is not longer just a switch or a router, it's a virtualized switch or router. Virtualization on the server level, and of course the containers came in as well. That's another level. So the traditional methods about port gets and reading SSH checks and all that stuff doesn't apply anymore in the new environment. In addition, it's all dynamic. It comes in and goes quickly. So the static routes that you set up for monitoring before gives you false alarms. In the middle of the night, a VM moves from one hypervisor to another. If you do it with SSH or port gets, you get an alarm and says the server disappeared. So all that are the new things that are in there, and the monitoring tools have to adapt to it. And how is it done? Through APIs. Every tool now has an API. You go to the API, you really have to discover, rediscover, and synchronize, and then decide then how to move the monitoring and adjust the monitoring. So where comes OpenStack in? OpenStack, it's really like the platform to do the virtualization. It has the service-oriented architecture, elastic compute. It's great, but how do you monitor it, right? Everything should be there, but everybody knows that's the architecture of OpenStack. A lot of components, service-oriented architecture. Every element has their own API. So again, instead of doing checks before per port, you have now APIs to go after. What's really necessary and what we worked on is like unifying all the APIs and have one API for monitoring across the whole OpenStack. That's really what you need, because you have 5, 6 components. You have the same problem as before, that if something changes, if something gets updated, you have to reconfigure your API. So you really need a service to encapsulate all the monitoring. So these are what the checks that come out of the API. You see there are for hypervisor, for VM machines, and even more, there are all these metrics that are coming out you can collect. So now that you can collect them, that's easy, but you have to have templates to apply that. And that's what we are showing here. That's what we did in our product. It's creating monitoring templates for the checks you're doing that you can then apply to a class of VMs or hypervisors, this monitoring thresholds, because you have no time for each check to go in and define the threshold. You have a class. You have to define the class of thresholds. And what you have to do is as well percentage about. It's percentage of memory, percentage of CPU, and so on that you really want to alarm on, and no longer on a value like 2 gigs of memory or 15 processes and so on. So you need template-based monitoring and API to really monitor virtual environments. But of course, that's not the whole story, right? Everybody knows. So yes, you can monitor in OpenStack through API. You have all the data in, right? The virtual infrastructure is there. But your OpenStack runs on a legacy network. There are other servers out there. There are storage racks out there which are not covered by the APIs from OpenStack, right? You still have to monitor that. So you still have application checks in the traditional way that you have IPMI from the hardware level. You have like process counts of even inside OpenStack, you have MySQL instances. You want to look how well is MySQL instance for my identity store running. So you still need the traditional checks. There can be port gets or SSH, no problem, but you still need that. But so you have to combine all that. So that's where my point goes through. And then the next thing is like the provisioning. It's a whole class of other machines that you have there. You have, again, servers and softwares and API for provisioning. So you collect this information as well. Since you're talking, you have containers as well in your environment. You have performance data. So you have a lot of things that you collect. But what you really want to have, it's a unified view across all the data. That's the point of what you want to do, that because the interaction of all these elements from OpenStack, legacy networks, provisioning tool, performance data, and containers, you need one view if you want to troubleshoot. You want to know on which VM this container it's running on which hypervisor it is, and which network it is, and what storage it is using. It's very important that you have one point of view for the whole thing. And you need a standardized data collection. That's the other thing. So you need API everything for monitoring. So whatever you develop, you need an API to collect more data. So what's a unified view? It's really, we know the problem with open source. They have all the siloed tools, which you have individual tools that give you a snapshot of what they are good at. Here you see Horizon and VMware and Icinga, for example. They have their views, but if you want to troubleshoot, you have 3 screens open and you try to figure out what's going on. It's impossible. What you really need, it's a unified view in the whole thing. You need aliasing of names, because as we know, sysadmins don't talk to each other. The network administrator gives a name to a device. The OpenStack, when you create a VM instance, you give a different name. And then containers have IDs, so it's almost impossible then to really tie together. The correlation of monitoring, you need an aliasing tool. So it's really important that your tool supports aliasing, that you can say all the checks are coming in. That's when I talk about standard data collection. All the data comes in. You want to see it on the one device on your visualization. And that's what I show here below in the graphs. And then, of course, you need role-based access and dashboards, because each group, it's different, right? You have the network group, you have the virtualization group, you have the end users, you have the business users, and so on. So you want to have different dashboards, but still showing all the data that you collected. So how does it look in reality? Here's just an example that from network storage, you get SNMP traps in. Then on the hardware, you get IPMI and SNMP checks in. So the host name could be direct server 1 because it runs on a different IP, different naming comes in. The identity server that OpenStack runs on, it's a SQL on a port, and so on. So it goes to the operating system, the OpenStack API. So it builds up. So you have a whole stack. What you really want, what I mean by aliasing, it's like you see all the different names there, that they all go together to one host. And what I have here on the right side, you see that you have IPMI checks and the virtualization checks there on the one group, so you can see if there's anything wrong. You see an impedance mismatch between what the operating system thinks it has, what the VM thinks it has, and if there's a mismatch in the configuration, you see it here when you see all the checks correlated. So that's really important that you can start grouping the things. And so aliasing, it's the most important thing in virtualized environments. So what's the next important thing? It's like you need monitoring that's dynamic. So what the monitoring tool has to do is like querying, get the inventory what's out there for all your containers, all your VMs, all your hypervisors. It has to get in and load that into the monitoring system. And then the next step, it has to get the metrics for all that. And then if anything changes, it should be the monitoring should be adjusted. So it's like a flight recorder. When it starts up, you want to collecting data because you don't know if your VM, you don't want to be asked if you should monitor the VM. The VM out of the box should be monitored. As well, the virtualized network, the virtualized storage, everything should be monitoring from the beginning when you get started, because if it fails, you want to look at the history. So performance data, it's an important thing, but as well, continuous operation, synchronizing the configuration, reconfiguration of plugins. Again, if the threshold changes, if you move from one flavor of an image to another one, you say I shouldn't get an alarm because now I have a higher threshold, because again, you're using percentage for alarming. so you don't get alarms, and collection of the data availability and performance data. That's for troubleshooting, what you really need. So I'll just click through here. So what you really want to do in an OpenStack, you want to use Fuel, for example, for configuring your whole configuration, because there's still, as I said, the SSH checks in there. You still need the keys, all that stuff. Fuel has all this information in there and can help you to configure that. So that's why the plugins, the Fuel plugins, help you to configure your whole network. And of course, if in the Murano application catalog you have the monitoring tools like I put in here, Icinga, it's a very popular one upcoming that has an API that can be integrated to use to monitoring it, then you can start monitoring the whole thing. And what here I have on the top, it's like the solution that Groundwork has, the unified monitoring. We have an API monitoring for everything, combining the traditional monitoring and the API monitoring in one tool. What about performance data? It's the same thing. So you have to collect all the performance data that comes in from any source. So you want to have one API that you can send all the performance data in. What it means, all the data you collect, you send it to a backend. OpenTSDB, it's a perfect tool for doing that. And of course, on top of OpenTSDB, you have Grafana. Then suddenly you get the performance data across your whole system. So again, if it's the network, if it's VM, it's the hypervisors, storage, you get all the performance data into your system. And in the UI, then you can combine it with the other availability data, with event data that you have. And it's the perfect tool for troubleshooting. So what it comes down to, it's like everything API. So what you really need, collect all the data through the API. Have a central point for collection, data collection. Do the integration. That's the thing where you do the aliasing. Again, I get back to the aliasing. It's the most important concept in the world we are today, about so many tools, so many silo tools, so many naming conventions. You have to have a mapping, and that's what the aliasing is, of names, so that you can then present the data in one view. And then of course at the end is visualization, having nice dashboards, having a structure that gives you really a view into your infrastructure across all the elements. Again, the legacy network, virtualization networks, containers, everything that's out there. So that's really like what today's world looks like. You have the API everything. All the tools that are coming now in open source have an API, which is a great thing, so makes it easier to integrate. So what I here have the data collector hub, what we call the cloud hub, is really like you plug in just another API. Okay. So the benefits, I don't want to go to, it's like the APIs, you can integrate whatever you want. The best of breed tools you can integrate. So there's no vendor lock-in, so you can combine the different clouds and so on. So by doing all that work, going through the thing, it's like trying to create monitoring for the IT infrastructure. It's like virtualization requires new techniques. It's API. Don't forget the legacy. It was easier to define aliasing than making network administrator with virtualization administration that they talk to each other. So we had to come up with another concept that gives the IT manager and the DevOps a tool, and that was aliasing. So the conclusion, it's just like it's open source tools are driving the innovation. I think that's clear. We see that here at the convention. And DevOps are really now driving the whole infrastructure. So the traditional sysadmin, in my opinion, it's gone. And the DevOps really define, we need resources, we need to do this one, give me the best tool to do that. And that drives everything. And again, OpenStack, it's open source virtualization platform. There's no question about that. And there's a lot of momentum there. Okay, that's it. So that was